Welcome to clickmyproject.com. The title of this paper is Agglomerative MeanShift Clustering. What is MeanShift clustering? It's nothing but an algorithm which is a non-parametric clustering technique which does not require prior knowledge of the number of clusters and does not constrain the shape of the clusters. The procedure seeks out the local modes of the distribution which is calculated by the kernel density estimation. This is done by initializing a number of mode finding vectors in the feature space and then moving them towards the local mean. The most important application of this algorithm is a non-parametric mode seeking and clustering. The application of MS mode seeking and clustering include image smoothing, image classification and segmentation, image clustering, text classification and clustering, denoising and visual tracking, etc. Recently, the extensions of MS clustering algorithm from Euclidean space to analytic manifolds setting are exploited in some of the existing systems to address the problem of motion segmentation, multi-body factorization and object categorization. In this paper, motivated by the query-based nature of MS, we develop a highly efficient query set compression mechanism to accelerate MS clustering. The basic idea is to construct a family of d-dimensional hyperellipsoids to cover the current query set Q, in hope that points inside each hyperellipsoid will converge to the same mode via MS iteration. For example, for a given query point, the hyperellipsoid is constructed from a lower query bound function using the KDE. It is observed that the number of covering hyperellipsoid is much smaller than the size of the queue. Then the centers of these hyperellipsoids are taken to form a new query set with the size dramatically reduced. Likewise, we will be performing iterative query set compression mechanisms and will be finally achieving the final query set. This naturally leads to an agglomerative hierarchical clustering framework. We call that as a AggloMS. A tight upper bound of the convergent query set size is derived, which guarantees in theory the speed up the performance of our AggloMS algorithm. For the purpose of algorithmic speedup, in this paper we develop an agglomerative MS clustering method along with its performance analysis. This method, namely AggloMS, is built upon an iterative query set compression mechanism which is motivated by the quadratic bounding optimization nature of this MS clustering algorithm. The whole framework can be efficiently implemented in a linear running time complexity. The main contributions of this proposed work is to present a fast MS clustering method by developing a query set compression mechanism. Its clustering accuracy's performance is competitive to those existing MS clustering acceleration strategies. This shows that AggloMS can be naturally extended to an incremental version which performs comparably to its batch counterpart, and meanwhile the memory usage is parsimonious. Now I will explain the proposed work which is to be carried out. Initially, the document dataset is collected. Here we are collecting the 20 newsgroup dataset from the internet and we will be processing with that. Instead of that document dataset, we can also collect image datasets for image classification and clustering, etc. The input query, this is mainly based on the input query. The input query is given for the retrieving process, that is we have to retrieve some documents or some images according to the query which we are giving. The query is pre-processed before proceeding with the further analysis because the query must be in a reasonable format to retrieve the documents. The idea is to construct a family of d-dimensional hyperellipsoids to cover the current query set Q. For a given query point, the hyperellipsoid is constructed from a lower query bound function. After forming number of hyperellipsoids, it is observed that the number of covering hyperellipsoids is much smaller than the size of the query. Then take the centers of these hyperellipsoids to form a new query set with size dramatically reduced. Such a query set covering procedure can be iteratively run until a sample set of hyperellipsoids are obtained. Hyperellipsoids are nothing but the clusters. That is, we are obtaining some clusters with some point as a cluster head. And here the cluster head is called as hyperellipsoid centers. Now I'll explain the system architecture of this project. The first will be giving the query input, and for that query input we will be performing query set covering operation. For that we will be finding the reference set. For finding the reference set, we have to compute the covariance matrix for that query set, which is with respect to the document set. After that we will be collecting the hyperellipsoid centers, and then likewise we will be performing iterative query set covering process, and finally we will group those query set points obtained as a cluster sentence. Then we will find out the convergence analysis. Convergence analysis is the last step in which we will get the final set of query set which is covered by the clusters. Now I will show the demo for that project. For that we need NetBeans and WAM server. WAM server access the database. For that we will be using MySQL. In this, after opening the project, click home, select run file, click browse and select the documents which are placed in D: dataset router 1, and select some documents. Click open. The document contents will be opened here. Next, perform pre-process instant, and in the while stop words and stemming. The stop words will remove, and then for words like that, and stemming will be performing the suffix removing operation, and from that will be giving query list. Query list in the sense it is placed in the dataset 1 router. q1.txt is the query set for this dataset, and you select open, and the query set will get open. Query set in the sense the terms which can be given as a query to these documents. Will be computing the frequency in the sense each word in the query set is contained in whichever document with frequency. Then next we will be performing the Mahalanobis distance between the query terms, and also between the query and the document. For that we will be performing we will be finding standard deviation, and this is the covariance matrix for each document which we have selected. From this we will be calculating the document distance. After that we will be finding the query distance which allowed to that document. For example, document 1, the distance between document 1 and computer is this much, and after that we will be finding this is now considered as the cluster centers. With this as cluster centers, now we are going to form cluster. Query set covering, we will be computing the terms in each document, all the terms present in each document, and we will be finding the frequency for that, and now we are forming the cluster. Cluster in the sense with head, with comparing with the cluster centers, it will be performing the operation. For example, the query term for document 1 which we have selected as the cluster center is computer and some other things. First we will see about computer. For computer, the clustered objects in that document are computer, hardware, communications, data, network, formats. Likewise, we can perform any number of documents for any number of query sets. From this, our project ends with this result. Likewise, we can perform this operation for both images and text files. Thanks for listening the video. Thank you.